ponendo una línea funcional de tipo la mujer ya
Good evening.
good evening, sir.
I'm glad to see you, even though it's not easy for some, but we can try to recap Friday. So the Friday schedule we saw, who can call me one point that you remember on Friday?
So stationarity.
We saw stationarity. Yes. And anyone else apart from you and Roy? Roy, yes. Anyone else who can recall what we saw last Friday? Anyone? By analysis in data or even also anyone else? We saw
Yes.
some classical assumption for the OLS.
Yes. Remember.
OLS assumption. What else?
So auto-regression, and
Oh, we saw even also the auto-regression, auto AR, auto-regression, moving average. So now we saw what else? Parallelogram.
so
Can you report? Can you let me know? Anyone else?
Dunker
We saw?
for them.
Yes, we saw the tests, unit root tests, unit root tests involving DF, Dikefura, augmented Dikefura, also small for Philip Felon, PPF, PP. What else? We test for the EViews, EViews and stata for the unit roots. Or remember the drunkard? The story from the drunkard? Yes, random. Yes, yes.
Random walk.
Yes, it was a random walk. Random walk. So for those who can capture, yes, let me just minimize for those who can capture Fridays, today it will be very simple to continue, right? So we saw stationarity or else assumption, ARIMA, auto choreogram, unit roots, and furthermore, we try to do some practices from reviews and stata and random walk.
Also
Stationary. What do you mean by stationary? When I'm saying my GDP is stationary, what could be the indicator? My GDP or my inflation is stationary.
I've seen very similar
tell me in the middle, put it 0.
So it should have the same.
here and me.
It means the expected
Expect
YT, you see, expected YT should be equal to my mu. And the variance, the expected YT for the variance the expectation for the variance the expected variance will be equal to sigma. So these are the two principal or three principal. Regardless to a function of time, right? Regardless to a function of who? Time. Who can recall me one assumption in OLS?
that is
One assumption in OLS? Yes, please.
explanation.
The OLS assumption should be
Linearity.
is linearity a plus bx should be equal to y. So my x should be linear, right? The second one, multiple linearity. Hey, it should be a zero. It's no, it should be a zero. See, can go back? Yeah.
Whatever you
This one is B.
Linearity no collinear. But we can't go far, right?
What's the function?
So the ARIMA is based on univariate. Univariate model. Why do we test univariate model? Why do we test univariate model? Why do we study ARIMA, autoregressive moving average? So why? Okay. So when I say autoregressive moving average, it's supposed
Find the differentiation.
yes to find the differentiations, but yes, it's correct. But when we are saying autoregress, it's all about looking at the variable which is explaining itself. It's possible that today's inflation is based on December inflation. So I will be looking at the behavior of one series, not any external factors which is affecting my y. So it will be yt depend on the previous information. What is the characteristic of a random variable? Let us keep So the first characteristic of a random variable is that the expected UT is different from mu, right? And that the expected variance it is different from a constant, right? Okay. Okay, I will be introducing the unit roots. So the test for the unit roots, the first one is DF. DF stand for DK Fura. Stand for the DF. Why do we test for the unit roots? Why do we test for the unit roots? Why do you test for the stationarity or non-stationarity? It's because our macro variables are not stationary. It is a random process. Today is when I don't know my saving tomorrow. I don't know my consumption tomorrow. I don't know the government budgets for the next year. So it's a random variable, right? So that's why the fact that we have a macro variables which is changing. So our macro variables are not stationary. So we need to test to know whether we can use a series which is stationary or not. So one of the tests that we are using is Dikefura. So this is a test for stationarity. And the stationarity stand for stationarity test. So one of the tests is Dikefura. So we assume I'm looking at the GDP. Today's GDP. Yes. Today's GDP being with a drift plus GDP of 2025, 2026, beta 1 plus my error term. So the GDP is of which country? Let us use Germany. So the GDP of Germany. Let me just choose a random country, Germany, right? So we are looking at the GDP of Germany. So yes, the previous GDP is trying to influence today's GDP. So I'm trying to look at whether the GDP of 2026 will be a bit closer to the GDP of 2025 or for a country of like Germany, right? So I'm going to test one series. So a decay fuller or a unit root is happening for one series, right? Not different series. So if I have y equal to a, b, x, so I will be testing for y only, and even also test for x only aside. So if I have maybe, how many parameters do I have in this equation? Let me just ask you one question. How many parameters do I have in that? Two. No, I'm seeing three. Three parameters. How many parameters do I have in that equation? Two parameters.
So I'm taking X as parameter.
It's a parameter.
It's two.
It's two. Are you agree with two parameters?
Yeah.
Who agree with three parameters? Okay. Yes, it's correct. So you have okay, we have two parameters. So which one? Y and X. So both Y and X should be tested for stationarity. So the reason why we are testing for stationarity, we want to look at Y. Sometimes Y can go in this way, go down, and then my X can go in that way, right? So this is my X, this is my Y. So I want to see both my X and my Y, whether they are stationary, right? So not at once, but select one by one. Any question? Any question? So that's why if I say the GDP, so if I want to look at the DK4, I will test one test only, this one. And then DK4, the one who discover, say that, so if you want to test one series, it will be YT will be equal to alpha, a drift. So this is what we call a drift. A drift. So a starting point, the inception. The inception, where I should start, right? So where I should start could be equal to 0 or could be equal to a number. Plus a letter which is called rho. This letter stands for rho. You have learned in mathematics, right? YT plus my error term. And then he say, my null hypothesis should stand for that the rho, if rho is equal to 1, I will be suffering the unit root. I will be suffering for the unit root. When my h1 is equal to rho which is less than 1, I will not have a unit root. A unit root. So the DK4 is testing this rho only, right? That was the first test. The second test is saying, instead of testing this coefficients rho, he's gonna check for the error term. How I will be able to check for the error term? I will be, so the second test is called augmented DK4. Augmented DK4. Augmented DK4, what he did is to take the first equation, right? YT equal to rho plus, okay, plus, so essentially this is my inception plus rho times YT plus error term. And I'm assuming I want to see the impact in my error term, whether it is not changing. So that's why augmented DK4 applied, oh, sorry. This is -1. Today, tomorrow, no, yesterday. Sorry for where I just omit the lag, -1. Yes, it's a -1 because we are looking at the previous GDP. So my previous GDP should affect today's GDP, right? Are we together? Then the augmented difficulty, because it's searching for the error term, the movement in error term, he applied the lag for both sides. Negative yt1, which is equal to rho plus c. No. Yeah, the constant, the drift plus rho yt negative 1 minus yt negative 1 plus the error term. Do you see what the augmented decapola is doing? Take the decapola and then we just subtract the previous run. It's like Eric is discovering something, but Steven is saying, okay, I will just depend on Eric equation and then just add something or deduct something. So these decapola, they are the names for the researchers. Decapola or augmented decapola. Those are the names of researchers. So what he did was to take the decapola model, the first one, this one, or the other one, and then subtract the lag. That's why it is called augmented decapola. There is something abstracted from the decapola as an original model, because the decapola has some limitation. So that's why augmented decapola try to improve to make it better. In your research you recent, okay, supervisor will be saying, okay, please use augmented decapola and flip colon, and then he's skipping decapola. So the reason why he's skipping decapola is because the weakness in decapola, he didn't taste this error term, the impact of this error term. That's why we normally use ADL and PPP. PPPS, Philip Fallon. So the ADF, it is the augmented decapola, right? Stand for the augmented decapola. What are we going to see? What are we going to see here? So it will be the change in YT equal to our drift plus, so this will be the common factor, right? So it will be my rho negative 1 brackets YT negative 1 epsilon. No, alpha, no, error term. And then the decapola null hypothesis was saying, instead of using this factor, he called these changes alpha rho negative 1 to be rho, not to be delta. To be delta. Yes, this sign is delta, right? Delta. And then the hypothesis was saying the delta, who can remember the rho? The rho for the augmented decapola was 1. Okay, can we replace 1?
0.
If we replace 1 minus 1, it will be equal to 0. The alternative was the rho which is less than 1, which means it's all numbers which is less than 1 deduct by 1. It should be less than 0, right? Any number deduct by 1, but this number should be less than 1. It should be giving me a negative result. So that's why here he end up by saying the sigma will be less than 0. It will be negative side. Any number, I have a number which is less than 1, deduct this negative 1, it will be continue to be a negative, right? So that's why the standard, the derivative should be less than or equal to 0. In normal case, for the good hypothesis for the augmented decay process, he stated that essentially the derivative will be equal to 0, right? And then the H1, the derivative will be less than 0. Now you can see he was able to also to take into account the error term as long as he make a difference for both sides. Because if I do a change in my side to another side, I'm able to detect what will happen in my error term because the error term remains stable at this stage because we didn't deduct YT. So as long as my error term is stable, I can know. But if my error time is not stable, I will be able to know it by having this delta which is equal to 0, which will mean that H0 which is okay, H0 which is stand for the delta which is equal to 0, its equation will be like this one. The change in my YT will be equal to alpha naught plus 0 times YT plus the error term. Are we together?
Yep.
The change in YT will be equal to rho plus the error term. In normal case, we can say if we remove the intercept to be the change in YT will be equal to my error term. Any changes in my GDP is equal to a shock. Now you can get the sense. Any change in my GDP is equal to a shock. Is that series stationary or not?
No.
That series is not stationary because any changes like this one, any changes from this point to the other one, it's a shock, right? So are we not having a base series to predict? That's what the mathematics was saying. So as long as I will be suffering for the unit roots, the change in YT will be equal to a shock, which also implies to say that my series is not stationary. That's what I want to mean for you. It was a recap for the Friday. Oh, I omit one, the last one. I'm omitting the last one, the PPT. No, the PP1. So, any question? Any question? The PP stand for Philip. The Philip. The one like this one. PP, right? So the PP, the Philip Felon, it's a long mathematical model behind it, but what he tried was to base on augmented decay theorem by saying the change in YT, which is equal to my drift plus the standard deviation, YT -1 plus my error term. He tried to take the error term to be power 2. He added power for the error term. That's what he did to make sure that as long as he's doubling the shocks to know the impact on his series. So that's why if you test for the decay fora, and then you test for the Philip Felon, and then the result is stationary, you confirm that the series is stationary. But one can can say that the series is stationary, and then the other one can reject the series is not stationary. Because one is testing the error term which is normal, and then the other one is testing the error term which is having a power.
What this way do they need to power the out?
So that
What
that
do you need?
it was his technique to confirm whether the shock even though the shock can be power without having an impact on his series. It's like COVID, the magnitude of COVID power 2 will make my series to be stationary or not. On the other side, to mean if you take a shock like COVID and then you put it to be a power, it will be having a big magnitude to affect your series. So nowadays, yes, please.
Yeah, preventive or
It's not preventing. To know exactly if the shock was small, what if we just making it as a power?
yeah.
How will it be affecting my series? It affects hardly, so we confirm that there is a presence of unit root. Yeah.
It's a unit root is a test to remove non-stationarity, right?
No, unit root it is to test whether the series is stationary. And then the method of removing it, I will let you know for the upcoming how you can remove the unit root test.
So,
How?
so if you want to know what
Yes.
let's find the stationarity. Is it only the unit returns that we use?
Yes. So and then within the unit root test, we need to look at the DF. Okay. Let me just write. Your colleague is asking a good question. To test for whether the series is stationary, which test are we using? I have to. Let me ask you one question. Today you consume, right? Your series of consumption is C. This is my C. It's my daily consumption. From January 1st to maybe January 19, I think. Yes, it's 19. It's a time series. So what I just consumed from January 1st till now, it's a series, it's an observation to test whether it's stationary, which test should I use? Very simple. If you want to test your consumption from January 1st to January 19th, what test are we going to use?
We need to test.
There is 3 tests, but you are going to let me the first one, the second one, try to 1 point attack. Which thing are you going to use to test for your consumption? Because your consumption can change. Today's consumption is not the same. It's not similar to the weekend's consumption. So the first test we'll be using augmented decay for ADF, right?
Yeah.
The second test that you can use PPP, yes. The ferric ferron, yes, ferric ferron. The last one will be
DF.
yes, DF. Those are 3 tests that you need to use to test whether your consumption series is stationary or non-stationary. That's correct. Very simple and understandable. Your daily consumption, if you test it, and then it's a time series, you can use three tests: ADF or Felon or DF.
So,
Yes, please.
so what will make a researcher to choose Philip Felon over Edward?
Behind, are you here?
So,
So to select the best test among this one, all the results are best. All outcomes from here is are the best. But the main use for your case study will be the two first one. For your study, you'll be using the two one, the first and even also the second one. You are going to let the DF because the DF is not powerful.
What's
Yeah.
the journey? We had more impact.
I hope we did a recap.
And that way we had it next.
if you double the impact,
We double the shots.
Yes, please. I think there is someone who was born here.
Yeah.
Someone who was born here, right?
so
I remember.
So these are the biggest shocks that happen alongside as long as we are learning time series, these are shocks that are happening within 40 years. And then it affects the global markets. So we start with Asian crisis, and then we move to the dot crisis. Dot crisis. When people were starting to enter in 2000, they thought it was the end of the year. And then all rich guys sell all their properties. So after selling all the properties, and then when the year was ended, starting 2000, they see nothing happening for the or they corrupts. So they were some bad information that the F is ending at this time, right? So the financial crisis was from the mortgage from USA,
Stuff.
These are mortgage. What do you understand by mortgage?
Loan.
Loan relating to house loan. So people took a lot of money for building house and then they fail to pay. They default. 2012, there is a debt crisis from the European one. They print a lot of money into the circulation. They print a lot of money into the circulation and then the economy died. So my economists, monetary economists, when money supply increase, what will happen to the price? What will happen to the price? The price decrease? Increase, yes. Okay. And then and then the impression is also increasing. So that's what's happened here for the debt crisis. Eurozone was was similar to the debt one, but the COVID you are aware of was COVID-19 impact, which affect the whole economy, the entire economy, and that the bank failed. In USA in 2023, there was a bank fail like what we call Silicon Valley banks were falling down, and it affects the whole market. As you can see those crises, if you are analyzing your data, your local country data will also be affected due to those data crises. Like for those who will work with COVID, okay, for those who will work with the periods which is start touching COVID, it will be affected by this series that happen. For example, any GDP for any country here collapsed down. So it's up to us to know whether the COVID-19 affects our series or not. Whether it's our national saving for South Sudan or Brazzaville or Rwanda or Chad or Cameroon. Which country am I omitting? Oh, okay. The Rio Sudan.
Gabon.
Yes. Gabon? Yes, all Gabon? Yes. Yeah. So this is why we study stationarity. That is the reason why we study stationarity, because alongside the time it was a different shocks. So it means the results that we are seeing, it's a stochastic. Anytime we can have another shock. We normally know that the shocks that happened was COVID-19, but no, it's not COVID-19. Before even COVID-19, it was Eurozone crisis, the debt crisis, financial crisis. Okay. So have I answered your question well? So the reason why we are learning, we are spending a lot of time on stationarity, it's because of this thing that is happening during our time horizon that we are going to analyze, right? Today we are going to have a good topic. Hope to enjoy with you. Let me see. So model specification. Before further analysis, I want you to understand about the model specification. Because in the assignment that I gave it to you, was about to model the mathematical one and even also the econometric one. As long as you don't understand this one, I will be in lagging. I will be in lagging. I will be somewhere. So I will hope to be behind. See? Okay. Okay. My topic today, we are going to look at the model specification. How would be a good model specific? What would be a good criteria for having a good model specified? My model should be underfit or overfit. So it's feasible to have a model which is underfitting, or is it better to have a model which is overfitting? Or is it better to have a model which is at least modular? So we are going to look both. What makes our econometric model to be well, or to be safe, satisfy the criteria? First of all, our model should be with a consistent data set. With consistent data set. What do we call, why do we care about data sets? Why are we caring about the data sets? Who can remind me? The reason why you are caring about the data sets? Please, class, participate.
Can
Who went to the bar and then drink?
we draw the information from it
Oh, don't say the story.
because we get
Yes.
information from it.
Yes, please.
So we get our information from it. So
Oh, we get the information about it. Yes, all our information is data, right? So the reason why we are caring about the data is this one, brew. Yes, brew. Remember the brew. Best linear and biased estimator. So we need to have good results. We need to have best linear and biased estimator. So unbiased, who watched yesterday match? Oral. Was the referee biased or unbiased?
it was biased. This one.
Okay, I can see. I can see. Yes. For you to understand in layman terms, the referee was was doing something. Okay. Let me assume your data is not, it will not be similar like the referee's why he didn't yesterday, right? Let me assume that your data set is correct, right? Right? I can see. You are a fan of Senegal.
Of course.
But I can see the fan of Morocco. Okay. The second one is to be consistent. The second one should be consistent with the theory. Please don't give me any topics or any model which is not related to an econometric or an economics theory, right? For example, you can ask yourself, let me see, one country that there is gap. Okay, let me take a random country. Let us take one country like it. Let us take like a country UK. We want to look at the inflation of UK, right? For from 2012 to 2026. So my Y is inflation, right? What will be the determinant of inflation?
Interest rate.
Interest rates. Okay. So my inflation is depending on, it's a function of interest rates. What is interest only can't affect inflation. Okay.
It's applied.
I can see the monetarists and macroeconomists here, right?
That's not it.
I want you guys to at least defend your position. If you say, okay, you want to come to work for the central bank, you need to understand the monetary policy, right?
So,
Okay. And then I have said that the best econometrician is the best economist, right? But not the other way around, right?
what is
Okay, let me just see. The determinant of inflation, your colleague is saying inflation. No, interest rates.
What are we doing at the down? That is
Yes, it's okay.
in size.
What about the demand and the cost pool inflation? So if we assume maybe our inflation is higher, we can look at the cost push. The cost push, what is the function of the cost push? There is wage, but before wages we have oil price. As long as gallon akagunguru, right? Gallon is increasing per dollar, right? Automatically the wage should also increase and then it affect the supply, right?
Yes.
So it's a wage, but before wage we need to have oil. As long as oil prices are increasing from 900 one in France to 1,960, it means the cost of living will be very expensive, right?
so
Okay. What else? The demand? It can also affect, it can come from the demand pool. So the main determinant of the demand pool, you guys have you learned monetary currency? From Bridget?
Not yet. Not yet.
No monetary policy.
Yeah.
But you have learned macro.
macro.
Yeah.
But so we know the demand truly is not even clear macro. So the
Yes.
demand for that. We need the cost push.
So the demand.
The demand, whether you want, I think it's the demand. If the demand is one
You listen. So the demand pool is coming from, yes.
inflation associated with the demand.
It's coming from which points? The demand pool. Who can guess? Who can guess? Who can guess? I need someone who. The factors that is affecting.
The inflation.
Yes. Should be the price. Should be the aggregate demand also. Cost of living. Yes, cost of production. It can be labor and capital. Let me just make easier for you. It will be labor and capital. So what I wanted to help you, if your model is concise, is consistent with the theory, to make it will make easier for your supervisor to agree the topic. It will make you easier the supervisor to agree your topic. So like here, the UK inflation, let me just put it aside. So the UK inflation will depend to be a function of interest rate, wages, oil price, GDP, which is in factor of labor and capital, right? And then it's giving an output. So this is my X, X1, X2, X3, X4. Now you can run your regression. You see? So you need to have, as long as you have a topic, please make sure like 50% to align with economic theory or economic science. Otherwise, it will be very difficult for you. Are we on the same page? Okay. So another point, the reason why you are learning theory, I know. Don't ask when you providing examples for whether it is in line with economic sense. It will not be there, right?
Break. Exogenous.
So our variable should not be correlated with error term. So that is the third one. We can recall this principle. People behind, who can just let me know once what do you understand by endogeneity? Okay, the principle is this one. If you can respond, you stay there. But if you don't respond, you come to sit here, right? So I want you to let me know. What do you understand by endogeneity? So no else sound of it. What do you understand by endogeneity?
You went to picture. Incredible. You're dying. You're on the day. On earth. And then it's a difference. It's like and then what we are saying there as the third principle, we need to look at our exogenous regression to be weak to correct you. Why do we care about the being corrected with the excess? It is because we assume that other factors will happen. So as long as we full the check, that's why we need to check whether our exogenous regression should be not correct with error term. So the covariance of my X should be different from the error term, which is equal to 0. And then that's where we confirm that other factors remain constant. The parameter should be constant. It's very normal for you. I will not dig in. The residual should be a white noise. Wow. A residual should be white noise. Guys behind, what do you understand by white noise? White noise, please. So white noise, it is confirming that the expected YT, my series, is equal to 0 or is equal to new parameter. And that the variance of YT should be equal to a constant. So that's what my residue will be normally distributed. Will be normally independently identity with a mean which is equal to 0 and then a variance with which is equal to sigma. That's what we mean a white noise. Okay. And the last one is that we include all arrivals model. Include all arrival model. We should not skip. So the second part, conversely, we are going to look at the incorrect model. What are the type of incorrect? Yesterday I sent you an assignment to just correct, to just brainstorm with an idea, bring me a topic. After bringing me the topic, try to make your mathematical models and arrange yourself to have econometric models. I don't want you to bring me incorrect model specification. I don't want you to bring incorrect model specification. So the model which is incorrectly specified should be the first one is that you are omitting the relevant variables. If you omit your irrelevant variables, you might have incorrect model. Meaning if someone who farm, and I want to look at the determinant of my yield. I'm a farmer, I want to look at the determinant of my yields. What will be my x? X1. Please, don't do assignments with the class. I'm a farmer. I want to look at the determinant of my yield. What will be my x? So the first one will be fertilizer, right? Second one will be the standard. The standard will be the standard. Yes, the standard. So this one I don't. The third will be the rainfall. The fourth can be photosynthesis. So to understand the photosynthesis, okay. That's good. What if in my model I'm just omit for example fertilizer? I will be just doing some incorrect model specification. When you see on the map I want to look at the determinant of turn. I want to look at the profits, determinant of turnover for maybe for example for Inyanja industry, right? The determinant of turnover.
Only you have to say the words in first. That's it. Yeah. That's what I said.
I want to look at the profit, the determinant of profits for any company in Rwanda, right? So I will be looking at, I can look at, see, the labor expenditure plus the capital expenditure plus what else? the taxes. Higher tax is affecting the profit, right? So what if I'm omitting this variable? What if I'm omitting the last variable? It will be also I'm just making my model to be incorrect. Right? If I'm omitting one variable, it need to be added. So I'm just making my model to be incorrect. If I'm adding a variable which is not necessary, so I'm also doing something which is incorrect for my model specification. So please, in your assignment, make sure that you add variable which is very essential for the model, right? Yes. The third one, the long form. I might choose to say my YT is depend on alpha naught, alpha 1, x1 plus alpha 2, x2 error term. What if my y is in a logarithm form? So what if my y is in logarithm form, yet it shouldn't be in logarithm form? Are we just making what you call wrong function form, long functionality form? Yes, long. Are we on the same page? Any question? Any question? Things are becoming theory, but you know.
So now the question,
After break, we are going to do something. But yes.
in our
Hey, you don't want it. That's good. Oh, okay. I will give you 10 minutes for break, just for short term, right?
in our model,
Not 30, but 10. To maximize, right?
so you talk about relevant language, relevant. So in our model, we have the error term, which is more the other values. Which one do we choose that is relevant variable? Which one do we determine is relevant? Whether you can do things. For example, in this one, I think myself, I would say that the one affects profit, which affects profit is mostly tax.
Yes.
So if I want to regress using tax,
That's why you keep joking with the data sets. And not one variable and see the impact on the other question. You can remove the other one and then see the impact. You can keep playing.
I'm playing with this.
Yes, we're playing with it. And as long as we having like, we can play with like 5 models, then see the one which is giving you the highest square. You also the more and possibilities. The one that's why you keep playing. Yeah, are you economics too? Your colleague is saying this, but I can't agree. I can't agree. My apologies to not agreeing your statement.
So
If you are an economy student, you can't. Okay, I can't release you at 8. It's impossible. It's impossible.
Yeah.
Otherwise, I will come in the morning tomorrow. I will request to come in. Otherwise, but I will try my best to give you 10-minute break, and then you can do as many practices after. Right?
Yeah.
Instead of that's why I want your fresh mind now, and then to making practices after break, right?
Horrible. دلوقتي انا ما بقفل 30 من اصل انا كان جهمتين وقاعد
Wow, that's good.
So some
Okay, can we proceed, please?
yes, we have no question.
Yeah.
So you said that we keep on checking the answer. You
Yes,
see there is a change.
you keep.
Now,
You keep
how am I
checking.
going to see if two variables affect y the same
At the same time,
same time,
and then
or
when
have the same effect on y?
so it is in terms of R square. You can use one variable and then you have okay. Sometimes you can use the R square and then get okay, you can use this variable only and then you get the R square of maybe 49. By adding the second one, it can contribute to 70%. So you see, you keep adding and removing and see the impact. You can keep playing with it, but we want to see it in practices for you to understand. So let this section be theory. I will just show you how you can just keep changing.
Because last time you were talking about the variables that affect us, the same they have the same effect in y. Or they are variables that are just that we can remove because they it's like can I show you? It's like the effect. We already have a variable inside that tells. For example, when we talk about if I talk about taxes, I talk about taxes, and after I have maybe revenue taxes, taxes. Yes, this.
So as long as, for example, you can just take two variables and then two variables themselves, they are correlating each other, right?
Yes, yes.
So you need to select one. Yes, one.
So it's like when we determine our modern when we economic model, we have to test for all of them
Yes.
to see the best fit.
Yeah. And even also the impact of having irrelevant variables is making you to have omitted. Is making you to have multicollinearity. As long as you're adding many variables, it's sometimes end by having multicollinearities. That is the effect for the second one. If you omit, you lose the chance to have a good R squared because you have few variables to convince what? You have few variables to convince on this one. Okay, please. Please. But by my sister, it was your statement. I didn't. Yes, your statement is good, but everybody is saying, "Oh, can we finish everything? Otherwise, I will not end. I will not end this session." So the error measurements, you can measure your error wrongly and then cause an issue. To have also incorrect stochastic specification, right? So, and then let us go step by step. The first one, let me assume we have this equation. So now we are back to the model, right? We are back to the model. Yes. Yeah, it is one, two, three.
No, like two of them. It's going to be something.
So we end January. I wish with the same things we end this month having a draft dissertation.
Yes, sir.
That would be our last assignment to have at least you, everyone. I think we're not used to have an individual assignment. We are not used, but you have it. Very serious. Most of my assignments will be very individual. I don't want someone to work for another. I want you to be a good economist for your both for yourself and even also for your country, right?
So much.
Otherwise, if you wish, okay, you can make it. Okay, let us start. Let me assume we have these equations. How many x do I have here? I have x1, x2, x3, and then my y. Let me assume my y is stand for the total cost for the production. My y is the total cost for production. And then my x is my output. It means my outputs, more outputs, it implies more cost. If I'm producing, maybe I'm producing lights. Okay, I'm producing pens. I'm producing pens, I'm producing whiteboards, and even also flat screen. So then it is affecting to have a total cost, a higher total cost for me. Well, if my model is changing to be this one, which x am I missing there? Which x am I missing there?
So yes.
X power? Yes, x power 3. Yes, correct. Because x1 is here. Furthermore, x2, but x3, I'm just missing it. So I'm missing x3. And then this, what type of error am I doing from the error that we learn? What type of error am I doing if I choose the second model?
Omitting.
It is omitting the important variable, right? So the error will be to omit the relevant variables. Okay. So if I omit, it means my other factors remain constant. Will be keeping this x power 3 within its equation, right?
Sir.
Yes, please. Yes, please. Hey, oh, we are together. That's good. Oh, okay. Let me assume we have this model. A researcher is assumed to use this model. We have x1, x2, x power 2, x power 3, x power 4. Okay, let me see. So if we include okay, if we assume we include this x5, no, x1, is it x4? And then it was not relevant for us, it will be also another mistake of including irrelevant variable. Yet our model should be this one. Sorry, our model should be ending here, right? Let me just write for you. So this is why. Oh, Jesus. This is why I equal to theta 1, theta 2, I theta 3, x1 power 2, theta 4, X VI plus UI. So that's how my model should be. So I should omit this x power 4, right?
For what?
Because it is irrelevant for us. If we add it, it is making our error term to be reduced. My question is this one. If we are supposed to remove this one and then we are adding it, what will happen to, what will be the covariance? The covariance of x power 4 versus our error term u. Will it be equal to 0 or will it be different from 0? If we assume we are using the first equation. If we are assuming we are using the first equation, it means if we include x power 4, our x power 4 will be correcting with the error term, and then it will bring an idea of homogeneity issue. So the fact that you can remove it, it will help us to remove the issues of homogeneity. That's how you can correct the issue of homogeneity. You remove one variable which is correcting the error term. Because its presence is correcting with error term. You can see here. The error term should be taken by u1 negative the x power 4. So the fact that you have just added within your model, it is making your model to correct with shocks. Which real example that I can give it to you? The perfect example for you is that my GDP can correct with FDI, and FDI can also affect my GDP. No, my GDP can affect the FDI. So as long as I have simultaneous equation like this one, so make sure that you understand that there is what we call homogeneity within this model. And then the only way to correct it, you can learn 2LS. 2LS will come into the last chapter. Two-stage least square. Now we are learning one stage least square. OLS. OLS is one stage least square. O stand for ordinary least square. So, and then chapter 4 will be two-stage least square, right? So we are going to correct this issue of where GDP can affect the foreign direct investment. On the other side, the FDI is affecting the GDP. So this is what I was saying. This is what I was saying. So this is what I was saying. The long format, if you use the logarithm, and then it is not in a proper time to be used, so you're going to have a wrong format. And error for the measurement biases, essentially we are going to, if we assume that our y star is stand for our y plus the epsilon, and then our x star is stand for the x plus w, That would be also a wrong error measurement biases. This one is very difficult.
The fact that we have the y star equal to y plus epsilon. Is it possible? Can we have another like this?
Yes, it's possible. It's possible. It's possible. Most likely to be simultaneous one. Simultaneous.
Epsilon stands for in this case.
So the epsilon.
Yes, because we have the
So the epsilon is the error term normally. This dub y and
epsilon y.
it's also the error term. Those are short error term. That's why we say it's an error measurement. We are measuring our errors in a correct way, which is making to have multiple errors in each and every x and y. So we don't have the unique error term. We don't have a unique error term, but we have multiple error term. So we have error term for x, and then we also have error term for y.
So we can do.
Yes, we can add it. This is mostly likely based on the data from being result from cooking. Have you heard the word cooking? Cooking. Yes, sir. You can cook it.
Yeah,
That's why you're going to do it. Yes, you can.
yeah, we can cook it. Try to.
You are going to cook your data. As long as you miss your data, you'll be cooking it. But what you are going to make is this one. It's the last mistake that you are going to make. If you miss data, sometimes analysts, when they miss data, they can cook.
We find the mean.
It's happened.
Now it just. They see that once
Okay. How?
What?
How? Oh, okay. Let me just.
Around video.
Yes, please. Let me just show you how.
Very good.
So I will not give you. I will not mention the country, but you listen to it. Oh no. Maybe. Oh, okay, yes. Okay, let me assume when South Sudan started to have a full governmental functioning, when was in 2011, sure?
Yeah, when it become independent.
Yeah, it's when, yes, I agree, but I know that the data was start 2015.
Yes. I mean,
I know. 2015, it's when at least most data state to be on live. Yes, the data set to be corrected. So if someone is saying he's looking at the GDP evolution of GDP for South Sudan from 2020, maybe 2012 to 2026. How did he get the data from before 2015? Maybe he has retrieved from ChatGPT or he has looked for it, right? So if we don't have the real data, and then you are just making your own data, you are cooking it, right? You have cooked it, right? Okay. Sometimes, for some country, the poverty rate, let me assume, poverty rate in 2010 was at 70. And then after 7 years, the poverty rate, I will not say the country, the poverty rate was at 39. Is it possible?
Yeah, it's possible.
It's not possible.
The government policy.
The poverty from 70 in 7 years.
It's like it's just
Oh my
how
goodness.
many
Oh, okay.
Sanction tell you that not possible. It's possible.
So in 2010, the poverty rate was at 70%. It means seven out of 10 people was in a poverty, at a poverty rate. And then after 7 years,
But it depends on the book.
it is becoming maybe it's 38.
It's two.
As a macro, it's impossible. It's impossible.
So what's the country? where it's so-
No. I can't mention. It's an example.
Politically, it is possible.
Politically, it's possible,
But
but
they cook it.
yes, normally it's not. Because poverty, it's a big thing. Even 5%. Okay, let us see. How can we just say Paya was to mean 5% decrease?
70.
But let me just show you the reason why it's by cooking. Let me just show you the reason why it's by cooking. And then in 2025,
It goes up.
it goes to 26. What's happened? What's happened?
They shifted.
There was there.
They shifted the policies.
No.
2017 and the 2025.
It's like you know the country.
The COVID is there in just like 2 years.
No, it's it's like
The economy was shocking.
It's an example. I'm not just offense, right? But what I just meant to show you, some statistics can lie. So maybe for a political reason, which is correct, right? And then if I'm in a good place, if I'm in a good place to lie the public, right? I can make it. But maybe for a political way, right?
Dysfunction.
But as you're a data analyst, you do your work, and then maybe your boss will decide. Are we just saying, instead of saying 50, okay, 57, let us say 38, or just informing the public that things is going well, but we can just recover from 27 to 26. It's possible.
But the public, they know.
Yeah.
Yeah, the public, they know. You are telling this scenario to have just like 50 million. I know I have nothing. Even if you are presenting those data, but I know that serve the time.
This is what cooking means. That's the meaning of cooking. We have no say. What's the meaning of cooking?
You see, my colleagues was against it, start to agree what is happening. It's possible. It's possible for maybe a political just make the public the country is doing well, which is good. So that's what I'm telling you. If to reach at that place as an economist, okay, you will do your job, and then
That's
your
the meaning of
policy,
cooking.
your policy guys to decide what
You don't tell the
want.
truth. You are just cooking. You're presenting it as it is.
But what if you are an IMF guy? But if you are an IMF guy, you will detect that there is a cooking, because IMF is coming to evaluate for each and every country that is within the member. With the membership. So they will say, oh, these numbers are not correct. Please show us how you calculate it. Or show us your raw data. It's possible to all cook perfectly, right? But for education purposes, please let tons here. For education purpose, we are trying to look at the model which is not fully specified. The errors are being measured in a biased way, right? And even also my Y is measured in a biased way. If you put your poverty here, and then your saving here, so which means so your regulation will not well be specified, essentially. Okay.
That's good. For the stochastic one, this is how the stochastic will be look like, but I will not delay. What do you understand by underfitting? So if it is underfitting, let us recap. If it is underfitting, my true model is this one. My wrong model will be this one. Who can detect the change? Who can detect the change between the true and even also the false one? Underfitting, it means I'm missing x3, right? So the consequence. The consequence is that I'll be having a bias being 0. My parameters will be estimated in a wrong time. And I'll be having also the variance which is not perceived. And my hypothesis will be not will be misled. So my HI and my hypothesis will be tested in a long way. How? You can remind us how we do hypothesis.
What's the question again? What's the question again?
So how my hypothesis test will be just misled due to the missing some variable.
It'd be like
We are not going to
the error time will be big.
Yes, the error time will be big. T calculated will be equal to the x negative mu over the standard deviation. Oh, the carry is not. Let me see the curve. So it will be T. Yeah, yes, by frame.
So if we cannot have a big error time, if we cannot have a big error time, also we cannot have a small error time.
Yes, which
So how can we determine that this error time is okay for this for the parameters or for the model? Because we cannot have a big error time, and we cannot have a small error time.
You can plot by normal distribution and then see whether it has both tail, and then test for normal distribution by predicting the error time, and then you can. We do have some tests for the residue to see whether it's stationary or not. Okay, to see that it is normally distributed. For as long as our residue will be normally distributed or a white noise, it's where we'll be confirming that everything is okay.
I think it's better to say it's normally distributed.
Yes, normally
Or
distributed.
big or small. Because big or
Yes.
small.
So if we have an error time that is not satisfactory, what's the first thing we look at? That is
Yeah,
not
time.
satisfactory, that is either big or small, what's the first thing we look at?
Look at that. If it is distributed.
Yes, we need to look at its distribution.
Yes, that's what I'm saying. After we have seen the distribution, and we
How
see-
can we solve it?
Yes.
So the only way to solve it is to start again adding a new variables within your regression, your models, or removing one variable from your regression.
So if we have a less error time, the tail.
No, we can say that we have a less or a big, but how it is distributed? Is it normally or not? Yes. The point here is to look at the standard deviation. So as long as my variance is not, the variance is not sigma, even also my standard deviation, the square root of variance will not be a constant. So which make my t, which make my hypothesis test to be misled. I can reject whereas I should not reject. Are we on the same page? Oh. So you can also do some efficiency in your estimation. The efficiency comes from the volatility. Efficiency. As long as I'm increasing my sample size from year 2005 to year 1996, so I'm losing the efficiency in my estimation. The second part is the consequence for the to omit the relevant variable. We are going step by step, but we are going to check here all those scenarios. If we are omitting the relevant variable,
The other one is
yes, it's the other one was undefeated. We need to add. So the other one was undefeated because the full model should have X3 and then is missing X3. Now on this page, we are having many models. We are having many variables, which is not important. How to resolve it?
we have so many challenges.
Yes, it means maybe our X2 or our X3 is not important. We need okay. So meeting the relevant variables. Okay,
Next one.
X1 is not important. Let's assume that X3 is not important, and then we remain with X2.
So why don't we have anything?
Sorry?
Why don't we have extra?
Yeah, it's possible. It's possible. Whichever X. Whichever X. It's by I don't express it again. So if our X2 is correct with X3, so then you therefore remove one variable. And then a quick example is that let me assume this Y is my cells. Don't count. No, this part. Let me assume my Y is my cells, my X2 is the TV advertisement, and my X3 is radio advertisement. So both the expenditures to increase my sales. So I'm a company who want to advertise. And then I want to advertise both radio, news, and the TV. And that eventually I'm advertising in one for one company. For example, I'm advertising for the radio one and even for the TV one. It's the same company. So the charge will be double, but the impact will be one.
Yeah.
Whether I advertise in radio or advertise to the TV, even with my clients can hear what am I doing, right? So these costs are related. I should exclude one cost and then remain with the main, which can influence to the sales. That's how economies are run. If you have your both X's which are affecting your Y, you can select the one that you can remove and the one that you can maintain. In order to have a specific mode, right? That's why as long as my X2 and then my X3 is correlating together, and then the correlation is different from 0, I need to remove 1. To have a bias, which means that my alpha B, my alpha 2 will be now biased. Will be unbiased, will be correct. Suppose you have a one value. Yes, please. Yes, please. Yes, please.
Yeah, I see you are using a lot of the Zoom. So for this, we have to use Zoom, right?
Yeah, we are assuming. But what I'm helping you is because of the assignment that I gave, I need you to make a good model. I don't need you to give me a hash model. No, to give me a hash model. Basically, just ask ChatGPT, ask Claude, ask DeepSeek, and then also think again. Is this model correct? If I add this variable, will it affect my wife? Or it's weird technology. I don't need hash or an impacted model. I want at least to check, even though you can ask AI, I need you to think if this model will have any. And you remember that there is a part where I also just include to correct date. You can correct past date and then try to run some try to use some regression and say the variable which is the public to the one. Otherwise, you'll be making your supervisor working very. But if you make your supervising working very easier, we make it to depend early as possible. Leave it to maybe early as possible, right? Maybe in August. What do you see you defending in August, or and then you go home and then you come back for the graduation. You don't need to spend your rent this year. You don't need to spend your rent in that year. Just go right to it. No, it's possible. I don't know because I'm always busy. That's why I want to help you in the assignment. I'm always busy. I want to help you.
So when you have, you know that you have development. When the regulation is so I'm saying you check
لازم تطلع ريال لا امريكا دي كلهم بالقاع
we can be run first, so we have to run have it. Now
like this one is going to because report
or we can pull that.
It is another thing that I want to say. If you want to test for the multiplicity in your Excel, you can just run the correlation matrices. You remember the correlation matrices? Okay, we are going to make it today, right? The correlation matrix, and then we look at the variable which is correcting at 80%. That's why we can detect whether the excess is correcting to it. And then we can just offset or substitute one part the other, right? Okay, this is again the theories. I want to skip it. What do you mean by overfitting? I have my own model with many x's. I should eliminate small x's, make less x's, less x. Or with the consequence? The consequence is that we have a higher variance. And then you can see the last one is multicollinearity. Multi, because we add more variables, which is this. We are still repeating. This is one. This is the impact of adding more variables within your model. Is to make your variance to be. If you remove it, you make your variance to be correctly estimated. Yes. Okay, I think this. So
It's a repetition. It's a repetition of what I said. As long as we have a weak overfitting model, it means our standard deviation will be higher, and it will affect our t-calculator to be higher or lesser, depending on how the results, how we are having, we are looking at the TPT. So TPT is, if it is lower, then we are having a higher t-calculator, we need to reject, or the other way around. This statement,
it's the change line is your friend that you can do.
yes, the change in variance which is the you see the efficient test. The efficient test assume that beta 2 and beta 2 are equal to 0. So take y. Then the alternative is not equal to 0. These are the tests. These are the tests that you can use to specify. Essentially, we are going to look at the last one, but the remaining we are going to do it tomorrow. We are going to look at the test, the likelihood test, which is comparing the two models. Compare whether I can maintain the first model with the second model. Okay. Graphical representation. Graphical representation. So if I have modeling probability, it means for the economists here, we are here, right? For data scientists, we are here, right? For data scientists, we say we are overfitting. This is how we say we are overfitting. This line is cutting towards each and every corner, like a snake, right? Select all the blue on the other side and then the orange to be downside. But for the economists, we are looking at the line is it's a cosine or a sine, but which is touching for each end of the point. That's why we say our model is overfitting. When we say the right model, at least there is one missing variables, but there is a line which can show the direction. And at fitting, I'm missing some variable here, but also I'm missing the other variables. Let me see another example. First, please, you can detect the change. You can detect the change. You can detect the change.
Any points. I omit. Even the lecturer omits during the project.
If the lecturer is omitted to bring the graph, the student will also omit some variable.
Okay. Anyone who can observe any difference from here to here, here to here, anywhere, and under heating and bulb mode, right? So the line is passing and then is missing the upper one and even also the down one observation. But the other one is trying to cover all the points at the same time. However,
He's always trying to capture everything.
yes, the last one is trying to capture everything. Most of the students, okay, most of researchers try to overfit. Yes, most of the researchers like is trying to make the movie good, but its result to have overfitting. is overfitting. You try to make your model well, and then it results in overfitting, which is not correct.
You want to transfer.
So what is the why did the overfitting?
So overfitting, I'm assuming I don't have any error. If I'm predicting whether you will come at school, what's happening, right? So I'm predicting, and then the actual result is correct. Now, in normal sense, it's possible that I can predict that you will come at school, and then you do come at school. At least 1 out of 10, I can just succeed to predict 8, which is the minimum. But if I predict that you will come at school and most of this 10 times, then you are able to come at 5 times, my model will be underfitting, right?
So,
Your name, please. Let me just use this example. So if your name, please. Balan. Balan. So Balan, maybe we are here. Balan will come at school, for example. Today is coming at school. We are near, right? It's correct. Today is come at school, not. The observation is outside. Tomorrow we come at school, not. The model is outside, right? Yes. The day after tomorrow is outside. We can see that out of 10, we are at least 1 or 2. Out of 10, we have succeeded to predict whether Balan will come to school 2 times, which means our model is underfitting, right? If Balan today is coming at school exactly, and then he's coming at school, but we are missing this one and the other one 2 times, and then 8 out of 10, we are fitting with the results. So we say our model is at risk. What if we are predicting Balan is coming at school and it's coming at school, the results, same thing. So we are overfitting, right? Will you agree that model, impossible? Each model should have an error, right? At least. The best economists believe in error, right? If you are predicting also, you should have an error. If you miss an error, you'll be having an overfitting. So I don't want you to have a model where you know having an error, because it's impossible to predict. It's impossible that at the central bank to predict that inflation will be at 3%, and then automatically every time is at 3%. Because the IMF will say you are overfitting, it's a mistake. But it's impossible that I can predict the inflation will be at 3, and then the result can be 2.8. The result can be 5, okay, 3.5. So I'm near the 3 that I was expecting. So that's why we say overfitting and underfitting. So which time are we on?
8.
8:20.
Come back again.
Are you in the break?
Yeah, keep going. Keep going.
For what? For what? For what? It's already nothing to do.
I haven't yet decided. I haven't yet decided. You are the one to go out.
The one who was requesting for the break, you go and buy us thing. Account. Sorry. If you're requesting for break, you go and buy us thing. Bring it for us.
What do you want? Come bring it,
You
do
go
it.
and canteen, you bring what you want.
What I want.
You want energy drink.
So I can bring that.
Yeah, you bring
The one
it.
I had a friend.
I can bring the guy from Conti.
Lecturer, please help me to succeed. I'm in year 3.
Masa,
I still have one question. I know you're gonna be ready. It's a bad habit.
so is it easy to have a good mood? So like testing.
Give them 2 minutes.
Okay, you can have 10 minutes.
No, no, no.
Someone separate. You can also have
Il faut soit straight. Goes on. We only have 1 hour. Then those 1 hour will finish with. When you test and you see that it's then you have a when you are under yes, which can has the significant. But together, when you retesting, adding, testing, until, for example, if you test, you test again, and how it might be a good movie, you add it again, you have over 5 minutes. We choose the one we have to give it to you. It's an idea. So this is how we get a game. You can start your affiliates. What later then you can so
Yes, about that seven we already like finished it. Before you send the edit one.
Yes, I saw the trick that you was using.
What trick?
It was as quick as possible.
No.
It's important to finish an assignment in 2 hours.
Not in 2 hours. You mean I mean the first one?
the first one is not for the topics and research proposal. The
Yeah,
first one.
I mean the first one.
Yeah, we have submitted before you adjust it.
Oh, yes. No worries. I will consider the second one.
For the research proposal.
Such
So we
also
don't have to do that again.
You said the 4 minutes or so?
No. Still.
You can do the second assignment. I will consider the second one because the maths has changed.
Yeah.
It was I think on 33. Now it's on 50.
57.
Yes, I would consider the second one.
All right.
Take time and then look at, even though it can give you the wrong,
Yeah.
but I will go.
I put it on paper even.
Yes, I will go deeper and then correct.
Okay.
So the system can just inject one answer, but it's still correct as long as I will check.
If I check my own number and says correct, this is not correct.
No worry.
All right.
You have,
Okay.
you can continue. You can send multiple times. It's possible.
Because it's
If you
tell us
see
that
that you have made a mistake and then you stay within the time, you can continue sharing them.
our mistake
I
is
submit my-
that's submitted, but you have adjusted it again.
No worries. I will consider the last one.
Okay,
So
so
this one, should I submit it now or like I just cancel it?
You
Because I have written the paper.
you can cancel.
I can cancel it.
Yes, you still have time. Till Friday. There is no way to rush. You still keep revising.
No problem. That's it.
So this is my X2. I know it's X2, but still don't have X3. It's like notation only. So I need to remove this X3.
So I have added overfitting. It is to include more variables. So we need to make it easier.
More maximum reading that.
For you to make it easier, I can hear you reference x1 with
Percent alpha text to other
plus alpha 2.
that's really yeah.
Now I want to is this one. So omit this one.
This very quality lion
Because of multiple modes.
multiple night levels gamba kurenga ebyiri.
No, this x2 and x3 is operating each other. In this one, there is a correlation between x2 and x3. So I will never, if I'm advertising,
Yes,
so that my product can be
donut lips.
yes, I can't use the radio and radio the TV can select one to attract. So that's what the difference with this one, if you have one variable, it will make this one to influence the other. And then it will remove what we call the multiple linearities.
And then we get too many variables but twakoresheje zero wewe ifite kandi niba ifite nka many variables you have to have factor here so on.
And use what we call the correlation matrices. Matrices, and then check for the degrees of correlation. So what you mean, maybe you can write, understand what you want to mean. You write what's going to mean.